Tonight find Orion and look to the bright reddish star at his shoulder. That star is already dying, and it is so far away that the light landing in your eye right now left it more than 600 years ago, which means the truth is stranger than it looks. Betelgeuse may have already exploded. The flash might already be racing toward us across the dark, and we would have no way of knowing it yet. When it finally arrives, a second star will ignite in our sky, bright enough to read by at midnight, bright enough to see in broad daylight. For the first time in centuries, humanity will watch a nearby star die. Betelgeuse is a red supergiant, one of the largest stars you can see with your naked eye. It marks the shoulder of Orion the Hunter, a point of light that humans have gazed at for as long as there have been humans to look up. And it is colossal beyond easy imagining. If you set it down where our sun now sits, its surface would swallow Mercury, Venus, Earth, and Mars, and billow out into the asteroid belt. The entire inner solar system, lost inside a single star. It is also young, only around 10 million years old, a newborn beside our middle-aged sun. But Betelgeuse lives fast and dies young. It carries perhaps 18 times the sun's mass, and the heavier a star is, the more furiously it devours its fuel. In a tiny fraction of the sun's lifetime, this star has already raced to the very edge of death. Its deep, sullen red is itself a kind of warning. The color of a star so swollen and so cool that its stable years are already far behind it. We are watching its final act. A few years ago, it looked as if that act might be ending. Late in 2019, Betelgeuse began to dim, and it kept dimming until by early 2020, it had faded to less than half its usual brightness, the faintest anyone had recorded in over a century. Sky watchers held their breath. Was this it? Was the shoulder of Orion about to detonate? It was not. When astronomers turned the Very Large Telescope on the star, they found their answer. Betelgeuse had belched out an enormous cloud of gas, a surface mass ejection, and as that gas drifted outward and cooled, it condensed into dust, a vast dark veil that blocked much of the star's light from reaching us. The great dimming was not a death rattle. It was closer to a sneeze, but it was a sharp reminder that this is a restless, unstable star, genuinely near its end. To understand how Betelgeuse dies, you have to look inside it. Like every star, it survives by fusion, welding light elements into heavier ones, and the outward energy of that reaction holds back the relentless crush of its own gravity. Our sun will only ever fuse hydrogen into helium, and finally a little helium into carbon before it gives up. But a giant like Betelgeuse has the mass and the ferocious core temperatures to go much further. Each time it exhausts one fuel, the core contracts, heats, and ignites the next. Hydrogen burns to helium, helium to carbon, carbon to neon, neon to oxygen, oxygen to silicon, each stage faster and more frantic than the one before. The star becomes an onion of nested shells, every layer burning a different element around an ever-growing core. Our sun spends 10 billion years on hydrogen alone. Betelgeuse tears through these later stages in a geological blink. Carbon over centuries, oxygen in months, and the final silicon burning in about a single day. Because silicon fuses into iron, and with iron the star has signed its own death warrant, because fusing iron does not release energy. It swallows it. The fire that held back gravity is about to go out. At the heart of Betelgeuse, an iron core now grows, inert, useless, and heavier with every passing second. When it crosses a critical threshold, a little under 1.5 times the mass of our sun, it can no longer support its own weight, and it falls. The collapse is almost beyond imagining. In less than a second, a core larger than the Earth crushes down into a sphere, perhaps 20 kilometers wide, so dense that a single sugar cube of its material would outweigh a mountain. The star's infalling outer matter rains down onto that newborn core and rebounds, and a titanic shockwave begins to tear outward through the star. In the same instant, the collapsing core unleashes a flood of ghostly particles called neutrinos, carrying off almost all the energy of the collapse. It is that neutrino blast, as much as the shock wave, that finally blows the star apart. Betelgeuse detonates as a Type 2 supernova, shining for a few short weeks with the light of 100 million suns, a single searing point blazing against the dark. For those few weeks, no other star in our entire sky will come close. So when will this happen? Here is the maddening part. Nobody can say. Betelgeuse will die soon, but soon, to an astronomer, means any time within the next 100,000 years. It might be 100,000 years away. It might be next spring. It might, as we have seen, have already happened 6 centuries ago, the light still crossing the void toward us. There is no countdown we can read from the outside. The frantic final stages, the burning of neon, oxygen, and silicon, are all buried deep in the core, hidden from view, and the last of them is over in roughly a day. By the time the surface betrays any sign at all, the explosion is already upon us. We are, in the truest sense, simply waiting, staring at a fuse whose length we have no way to measure. When it finally comes, the first messenger will not be light. Hours before anything changes in the sky, a wave of neutrinos will sweep silently through the Earth, through the rock, through the oceans, through your own body, and trip the great neutrino detectors buried in mines and polar ice around the world. That ghostly whisper will be the warning. Somewhere a star has fallen. Astronomers will know where to look before the first light even arrives. Then the light reaches us. Over a few hours, Betelgeuse will flare to a staggering brilliance, perhaps rivaling the half-moon, but crushed into a single, searing point. It will be visible in full daylight, a star you can see at noon, people stepping outside at midday to find 2 stars hanging in the sky at once. At night, it will be bright enough to cast your shadow on the ground. For weeks it will blaze like that, then slowly fade, lingering as a naked-eye star for many months, perhaps a year or more, before it finally dims. Not since the year 1604, when Johannes Kepler recorded a new star blazing in the night, has anyone seen a supernova erupt in our own galaxy. Betelgeuse would be the brightest stellar event in all of recorded human history. A dying star that bright and that close. Should we be afraid? Reassuringly, no. A supernova would have to be within roughly 50 light-years to seriously wound the Earth's atmosphere, and Betelgeuse lies more than 500 light-years away, at least 10 times beyond that danger line. Its spin axis is not aimed at us either, so even its most concentrated radiation would sail harmlessly past. Betelgeuse offers humanity the rarest of gifts, a front-row seat to a cosmic cataclysm in perfect safety. Every supernova we have ever studied has been a faint smudge in some distant galaxy. Betelgeuse would be the first we could watch up close, night after night, with our own eyes. And what it leaves behind is a wonder of its own. The blasted-off outer layers will expand for thousands of years into a glowing supernova remnant, like the famous Crab Nebula. A vast cloud seeded with heavy elements forged in the star's final agony, the raw material of future worlds. At its very center, all that will remain of the mighty star is that tiny, impossibly dense neutron core, spinning alone in the dark, and Orion will have lost his shoulder. The constellation quietly rewritten for every generation that follows. So on the next clear night, find Orion and look again at that reddish star. You are seeing light that left it before your great-great-grandparents were born. A portrait of a star as it once was, not as it is now. Somewhere in the long dark between us, the truth is already traveling toward you. Maybe Betelgeuse still burns. Maybe it is already gone, and the flash is already coming. Either way, one day, perhaps tonight, perhaps 1,000 generations from now, the shoulder of the hunter will blaze, and the whole world will look up together at the same impossible new star. The light is already on its way. We only have to wait for it to arrive.